Hello everyone, it's Likan Chiu here, and so I would like to talk about basic demonstration on CryptoOps client app. There are actually 4 tabs which are digital signature ops, key exchange ops, secret key ops, and time-street development ops. All the provided functions are useful. However, many may come to a consensus that the first 3 tabs will be useful for common use. There are 2 common usage for digital signature. Although many confuses it with electronic signature, in terms of actual document forgery prevention, DS outcompetes electronic signature. There are a lot of details for DS, however, 2 of the most common usage for DS includes data forgery prevention and public keys forgery prevention. In the case of this application, it can also be used to support signing and verifying of key exchange public keys of the other party, which includes both normal and end-to-end encryption. There are only 2 DS algorithms supported at the moment, which are ED25519 and ED448. I will only be covering important parts of this application. The first thing is inside DS folder. There are 2 created folders. The first is cert, whereas the other is normal. If you do want to sign a document or data with any private key given or created from ON, AU, EU client app, you need to copy and paste the private key into the cert folder. For normal folder, just let the app create for you after you make decisions. One thing needs to keep in mind is that for cert folder, you can only input one DS private key into the folder. The second thing is type of DS. You will also see DSA function. If you choose cert DS, then you can ignore DSA function, else you need to choose non-cert DS and DSA function. If you are signing for files, you will see folders such as DS cert data TBS, DS cert sign data, DS data TBS, DS sign data. If you are verifying signed files, type of DS will look for files inside either DS cert sign data or DS sign data. Folder by your own input. If text sign or to be verified, it can accept both normal text and base64 text. After verifying signed text, it will also display in both normal text and base64 text. Since it primarily to an extent prevents data forgery, this can particularly be used to prevent or reduce the likelihood of scamming or spamming in the context of message or emails. Electronic signature when used in documents or files, it serves more like a form of acknowledgement instead of actual data forgery prevention. Of course, if you are a cryptography expert or nerd or InfoSec expert, you can also sign and verify sub-DS public keys from your cert's private key. Other possible use cases, if one knows how to develop and deploy, it can be turned into passwordless login. To explain on what is key exchange will be a long explanation. There's one important thing for both user and developer is that you can't expect to have a key exchange session when the sender is using X25519 algorithm and the recipient is using X448 algorithm. I will be focusing on ×3 Diffie-Hellman and Silkbox. You can think of Silkbox as a safer and faster way of doing RSA encryption or public key encryption, but it's underneath uses Diffie-Hellman key exchange. One thing needs to keep in mind is that once you encrypt data or files with Silkbox, only the recipient can decrypt it. The folders that were required by Silkbox were CAREx, Silkbox, TBE, E, and D. If you use Silkbox to encrypt files, then the application will look for plain text data inside TBE and encrypt it accordingly. E is storing encrypted files, whereas D is storing decrypted files. ×3 Diffie-Hellman, on the other hand, if you are a sender, you will see a pair of public keys for MAC and encryption, respectively. If you are a recipient, you will see 3 public keys for MAC and encryption, respectively. For sender on MAC public keys text box, the first is the first set of identity key of sender, and the first set of ephemeral key for sender. On encryption text box, the first is the second set of identity key of sender and the second set of ephemeral key of sender. For recipient on MAC public keys text box, the first is the first set of identity key of recipient, and the first set of pre-key of recipient, followed by the first set of one-time pre-key of recipient. On encryption public keys text box, the second is the second set of identity key of recipient and the second set of pre-key of recipient and the second set of one-time pre-key for recipient. When having end-to-end encryption or time-restricted Harmon session, both sender and recipient needs to change the public keys information accordingly. So in a sense, for sender needs to fill in 3 pairs of public keys from recipient. And recipient needs to fill in 2 pairs of public keys from sender. All in all, the actual usage for key exchange is to deliver secret keys used in encrypting actual data, be it in the form of text or files. Or in my case, there are 2 additional usage. The first being able to verify there's no man in the middle for this session. The second being able to encrypt and decrypt data in an RSA manner. The possible use cases can be delivering passwords from client to server or for secure long-term data or file storage, especially for NAS. This, along with the latter secret key ops, can be used to replace all existing data or file pre-encrypted with passwords. Symmetric encryption or secret key encryption is the current secure and gold standard in encrypting data or files. The problem it has is always how to deliver the secret key to other parties in a secure manner. I will leave the exploration and execution to you. This tab particularly serves end-to-end encryption. However, it might consider be the most tedious for end users. I will skip on this part. There are obviously a lot of information I skipped, and I'm sorry for all the tech jargons involved. This can be customized, but without the proper skill set, I don't recommend to customize such an important application.